Welcome! I'm Jim Plamondon, Technology Evangelist for Midnight Coders and its integration server, WebORB. In this screencast, we'll use WebORB's management console to inspect a .NET assembly deployed as a remote service, invoke that service, and generate ActionScript code including a client-side service proxy class that encapsulates the remote service, and a bindable model class that encapsulates the service's asynchronous result. Also, we'll refactor a Flex client to access the remote service using the generated code. This screencast's sample, Hello2, will reuse exactly the same .NET remote service getHelloWorldString deployed in the Hello0 sample, and refactor Hello0's Flex-based client to use the WebORB-generated service encapsulation code. Let's look at the web page that describes the Hello2 sample. It lists a prerequisite, your first WebORB-enabled .NET service and Flex client, also known as Hello0. Be sure to run the Hello0 sample, study its source code, watch its screencasts before watching this one. Take your time. I'll wait. The running Hello2 client application works the same as the prerequisites sample client. Press the invoke button, and after a slight pause, the string Hello World appears. The string was returned by a remote procedure call to a server-side object method. Let's start Flash Builder to look at the Hello2 sample's client-side source code. If you reviewed the prerequisite Hello0 sample's client code, as I'm sure you did, then you'll recognize this code as being quite familiar. That's because we're using the Hello0 client code as the starting point for this Hello2 sample. Note in particular the application fields, Hello Service of type remote object, and service model of type string. Also note the application method init, right here, in which the remote object, called Hello Service, is allocated and initialized. We're going to see these again shortly in a slightly different form. Now we're going to refactor the client application to use code generated by WebORB. We'll start by launching WebORB's management console, which is, logically enough, a Flex-based Internet application. Note the path name. It refers to the virtual directory of a specific deployment of WebORB, in this case the one I've named WebORB4. As you can see, the console has a lot of tabs. I promise to dig into these tabs in later screencasts, but for now we're going to skip right over those and click on the Services tab. Clicking on .NET Assemblies brings up a list of all .NET assemblies currently deployed into the ASP.NET application from which this console is loaded, in this case, WebORB4. Here is the Hello0 server DLL that we deployed into the prerequisite sample, Hello0. It contains the Hello Server namespace and the Hello World service, and its one public method, getHelloWorldString. Having selected getHelloWorldString, we can invoke it from the console. The result is a string with value Hello World, just as we'd expect. Below the invoke button is another button labeled Download Code. This button is not, I repeat, not the best way to generate code from WebORB. The best way will be described in a later screencast. However, this button is the simplest way, so let's click it and see what happens. In Internet Explorer, we get a file download dialog asking us to open, save, or cancel the proposed download. Since we're already in Hello2's client folder, we'll click Save. After a moment, we'll see a Download Complete dialog and Open Folder. we see a zip folder named WebORB.CodeGen.zip. Right-click on it and select Extract All. That brings up the extraction wizard and accept the default location by clicking Next. And Next again. This brings up the Extraction Complete screen. Make sure that the Show Extracted Files checkbox is checked, then finalize the extraction by clicking Finish. We see a new folder, Hello Zero Server. Select it, drag it to the Flash Builder application, and drop it into the source folder of the Hello2 client application. That will add the generated source to Hello2 client, and there you can see the generated source. The generated source folder contains 2 files in a folder. We're going to ignore the folder for now, but let's look at the first file, Hello World Service. It defines a client-side class called Hello World Service, which encapsulates and acts as a proxy for the server-side class of the same name. Its first field, remote object, corresponds to the Hello Service field that we saw earlier in Hello Zero client's application. Both are of type remote object. Its second field, model, of type Hello World Service model, corresponds to the service model field we saw in Hello Zero client's application. Having these fields in the Hello World Service class instead of our application class is a big step towards encapsulating the remote service. Now let's look at the Hello World Service constructor. It takes one argument, the model, that is, Hello World Service model, and does most of the work that we saw being done in the Hello Zero client's application init method. That is, it allocates a new remote object with destination, generic destination, which we'll see in most of our samples, and it mapped the source to the qualified class name Hello Zero Server Hello World Service, just as in the previous prerequisite Hello Zero client application. It then sets up event listeners for both the correct result and the fault event conditions, and does some more model initialization. Likewise, the listener functions do very similar things, but now they are encapsulated as methods of the service proxy class rather than as methods of the application class. Now let's refactor the Hello2 client code to use the generated Hello World Service client-side class. To do that, let's go back to Hello World Service, the generated client-side class, and copy out this useful comment. And paste it into our client-side application. The pasted code declares and initializes 2 fields, model of type Hello World Service model and service proxy of type Hello World Service. The copied and pasted code also imports the definitions needed by those declarations. Let's make those fields private to avoid a compiler warning later on. With those declarations in place, we can delete the application's getError method and getResult method, because that functionality is now encapsulated within the service proxy class. Likewise, we can delete the application's init function, because that is encapsulated by the service class's constructor, and also remove the association between the creation complete event and the init function. Also, we need to change the application's onClick method here to use the new service proxy instead of the previous hello service. Finally, we need to figure out what to do with the references to the old service model string, which brings us to the Hello World Service Model class. Looking at its code, we can see that it is a super simple class. It is declared to be bindable with no methods and just one property, get hello world string result, declared to be of type string. Let's open Visual Studio and look at the remote service class. The server-side class HelloWorldService has only one public method, getHelloWorldString, which returns a string. Going back to Flash Builder, we see that getHelloWorldServiceModel has only one field, getHelloWorldStringResult, and it is also of type string. So we see that for each public method available in the remote service, in this case the single method getHelloWorldString, the client-side service model class exposes a field of that method's return type, in this case a string named getHelloWorldStringResult. It's hardly worth encapsulating a single string in this way, but when remote services return complex types, or when the service exposes many different methods, both of which are very common, then this encapsulation pattern is immensely valuable. To maximize the benefits of consistency, WebORB's remote service encapsulation pattern should be followed even in trivial cases, such as that shown in this example. With that in mind, we'll return to hello2client.mxml and finish the refactoring to use the generated code. Specifically, here's service model. We'll change that to be model.getHelloWorldStringResult. And we'll make the same change here in the label to bind it to the proper value. Run it, and we see that it looks just like the previous prerequisite hello0 client. And there it is, bringing up exactly the same string which it brought back from the server-side hello0 server. With that, this sample is done. Happy coding!